just like the properties and stuff, or
Yeah,
graphs, or the equations,
a little
anything in
bit
particular?
of everything. Yeah, not just a little bit of
All,
everything, just locked in
all
center.
of it.
Let's see.
Okay.
There was one on the exam too, but can't.
So whoops. Let's start with the properties. So, because if you don't know what the properties are, then you're not going to be effective when you go to solve equations,
Right.
or be effective when you're trying to manipulate functions that have those logarithms in there.
Right.
Because you're not going to know what things could equal. So there's three major ones. So the first one is if you have just log base b of x plus log base b of y. The property says that as long as you're adding those two logarithms together and they have the same base, then you can multiply the things that are on the inside. So it would be log base b of xy. But you can also go backwards too. You can start with something that looks like this where it has a product and you can split it into two logarithms. So the properties
So it
work
goes both ways, right?
forwards and backwards. Yeah.
Backwards. Okay.
Okay. And then the other one, or the second one, would be log base b of x. And then instead of a plus, it's a minus. Log base b of y. And when you're subtracting, then it's going to create a fraction because you're going to divide. And the way you can tell like which one's on top and which one's underneath, whichever log has a minus sign in front of it, that automatically throws it in the denominator.
Okay.
And just as an example, let's say you had more than one. So log base 2 of x minus log base 2 of y minus log base 2 of z. So anytime you have a minus, you know you're going to have a fraction.
Right.
And anything that has a minus sign in front of it, that always goes down to the denominator, even if there's two of them.
Okay.
So the y goes to the denominator as well as the z. And so the question that a lot of people have is like, well, then what do I do with them once they're down there? It's like, well, you just leave them down there. They're just multiplied together. So the y and the z both go down. The x is going to sit on top. So if you're really wanting to know, like why do you multiply them in the denominator? Well, it's because the long way to do it is to factor the negative out. And then to use the property of the stuff that's on with the stuff that's on the inside. So if there's a plus sign in between them, what does that tell you to do with the y and the z?
To multiply them.
To multiply them. And then the minus sign says, okay, well, now you're going to take whatever's inside this log and put it in the denominator. So that's why the y and the z are down the bottom, and that's why they're also multiplied in the bottom.
Right. Yeah, okay.
Or you can shortcut it and just go, oh, if there's a minus sign, it goes underneath. And if there's more than one thing underneath, they're always multiplied together.
Right. Okay. Like a good rule of thumb, right?
Okay, and then the third one is when you have like log base b of x to the n. So there's some little exponent up there.
Mm-hmm.
That exponent can pull down. And it doesn't matter what the exponent is. It could be a whole number, it could be a fraction, decimal, something weird, positive, negative, doesn't matter. As long as you have an exponent, you can just stick it down in front.
Okay.
Okay, so those are the three major ones. There's one minor one that comes up from time to time. And actually, there's another one as well. And that's when the base of the logarithm matches the base here. So when the little number matches the big one, do you remember what that does?
I think it cancels it out, right?
Yeah, it cancels out. And you're left with just whatever the exponent is. So a consequence of that is if you have log base b of 1, what is that always going to equal?
Was that 0?
That's 0.
Right.
So it doesn't matter what the base is. If there's a 1 in there, it's just automatically a 0. So then a lot of people go, well, why? Well, it's because they're really using this property here, that fourth one.
Mm-hmm.
Because 1 is just anything to the 0 power. Right, so they kind of go a little backwards, and they change the 1 into b to the 0. And now they're just using this property and everything cancels out. And you're left with a 0. So the properties, they hold whether it's a log base b or if it's a ln. So it doesn't matter. So if you see an ln, don't like, oh my gosh, it's something like, no, the properties apply with that with the ln's too, because they're still logarithms. They just have a base of e.
Right, right.
Okay, so let's look at the simplification. So if you had log, we'll go log base 3 of 9. You're supposed to be able to simplify that without a calculator.
Right. Right, and that would be what, 2, right?
Mm-hmm. Yeah. Because 9 is just 3 squared. So now they match up and cancel. So the question is like, okay, well, what do you do if you have something like that, where it's not easy to make this number become a power of that one? And what you can do is you can just set it equal to X or to Y or whatever your favorite letter is, and then just change the format. So you can take any logarithmic equation like this, and you can always change it into exponential form. So do you know what that would be? And Helen, you can answer too.
I'm not sure on that one.
Okay. So you take the base of the logarithm, so this little number down here,
Right.
and it becomes the base of the exponential. So it's going to be 9 to the x. So the thing off on its own, that's your exponent. And then it equals 27. And then you just kind of start playing around with this and try to get your bases to match. So 9 and 27, they're both powers of 3. So 9 is 3 squared, 27 is 3 to the third. And then on the left side, you can multiply your exponents together. That would just be 2x. And the theory goes, if the bases are the same, then the exponents have to be the same. So it's kind of like the bases just cancel out or drop out. So you have 2x equals 3. So x equals 3 over 2. So that would be your answer for log base 9 of 27. That equals 3 over 2. So that's the long way to do it. And it'll work every time, even if it was for the first one we did, because you could just write it as, 3 to the x is equal to 9.
Right.
Then it's just a 2. But sometimes it's not as easy to see. If you're really good at them, you can look at this number, the little base, and you go, okay, what exponent does this need to make it a 27? So the people who are really good at it know that there's a 3 in common. So they go, okay, I know I have to square root the 9 to make it a 3. So that's a 1/2 power. And then 3 to the third is 27. So that's a power of 3. And then you just multiply them together.
There's 3/2. Got it.
Yeah. So that's the quick way, but you have to be pretty good with your exponents and like your powers and bases and stuff like that. So if you're a little shaky, then you can always go this route and it'll still get you to the same conclusion.
Okay, got it.
What if it was ln of e to the 7th?
I was just about to ask.
That would just be 7, right?
Yeah, we like it when ln's and e's are stuck into each other because they're inverses. Right. And they'll just cancel each other out. But it has to always be ln of e to the something or e to the ln of something. So if it's written this way, it'll cancel. If it's written this way, so the ln is your exponent of the e, it will cancel. But if it's written this way, so like you're multiplying the e to the ln, nothing happens.
Good.
Like you can't simplify it down. So if the question is saying, simplify or evaluate, I'm not going to give you one like this because that would, you would just be retyping it into the box. But if it was an equation that you were solving and you came out with this as your solution for some weird reason, you can't simplify it anymore.
Okay. Got it.
So just a little hint, if it says simplify or evaluate, you're going to be able to simplify or evaluate it. You're not going to just get something that doesn't do anything.
Right.
Oh, let's try, how about ln of 1 over e squared?
I want to say that's 1/2.
Almost. So you can't cancel them because it's not like it's close. It needs to look like this, but the e's in the denominator, so you're not going to be able to cancel it. So you have to do something here so that it's no longer a fraction.
Okay.
So basically, you just need to, flip it upside down or take the reciprocal, and you're allowed to do that to things as long as you also make the exponent negative.
Okay, so -2.
Yeah.
Okay.
And so you have to do something similar with this one, like ln of the square root of e, because again, it's not ln of e to an exponent. You've got e inside of something. So you always need to rewrite it so it's ln of e to the, and then you just got to fill in that exponent. So a square root turns into what exponent?
1/2.
1/2. So then we can get crazy and we can not only put it in a radical or square root, but we can also put it in the denominator. So you need to get it to ln of e and then fill in the exponent. So with this one, you have to do two things. First, you're going to write the radical of that square root as a 1/2. But since you're also taking the reciprocal of it, you're going to make this what?
Negative.
Negative. So it's to a -1/2. All right, let's try one more of those. Let's do ln of the, let's do the 5th root of 1 over e to the 4th. So it's the same game. You need to fill in the exponent.
Right.
And you've got two numbers in there. So there's a lot of options of where to put them and how to deal with them. But only one of them is right. So if you have a 5th root, does that mean there's going to be a 5 in the numerator of that exponent or the denominator?
That's going to be on the denominator.
Denominator, yeah, because it was for square root,
Mm-hmm.
because there's like an invisible 2.
Mm-hmm.
So if that's where you put it for a square root, then that's the same place I would put it for any other radical. So a 5th root, same thing, just stick it in the denominator. And then what about the 4? Is that going to go on top or is it going to go next to the 5 and do something there?
That's going to go on the numerator, right?
Yeah, on the numerator. Because it did earlier.
Right.
You know, with G and H, there was an exponent of 1 that was on the E. And where did we put it? Like on the top. So it's like, it might look like we're just making up stuff, but it is pretty consistent. So they're still all following the same pattern.
Right. And it would be
and then there's-
negative, right?
Yeah, and then you also need the negative because you took that and took its reciprocal. It's -4/5. Okay. And then what's ln of 1?
That'd be 1.
Mm-mm.
0.
That's a 0.
Okay.
Anytime there's a 1 in a logarithm, it's always a 0. If you say that ln is equal to 1, that meant that you were doing the ln of e, because the exponent on the e is just a 1.
That's the one, right?
And then they cancel, and that's how you get a 1.
Got it.
Okay, any questions on the simplify parts?
No, not really. I was gonna ask about the about letter I, but then you just covered it, so I'm like, okay, we're good.
Okay.
Yeah.
Okay, so then let's try to solve a couple of them. I'm going to do my best to make sure that they come out right. So let's go ln of x minus ln let's do 1 minus x. And then we'll set that equal to 2. All right, so when you're solving an equation with logarithms in there, your goal is to get them all on the same side. So if you have to move something over to do it, you need to do it. This one, they're already all together on the same side. So now you can just use the properties and start to combine them together into a single logarithm. So when you have that minus sign in between, does that mean you're going to multiply these together or divide them?
Divide them.
Divide them. And the one with the minus sign in front of it, that term goes underneath. The one with a positive in front, that goes on top. And then it still equals just the 2. All right, so once you get them combined together into a single ln, now you want to get rid of the ln so you can start solving for x. So you need the ln to cancel out. So what's the only thing that cancels an ln out?
An e?
An e. And they'll cancel out if it's written in one of 2 ways. It can be ln of e to the whatever, or you have the ln being the exponent of the e. And with this one, we can't just throw an e on the inside of the ln. So this option is out. We can't do it, but we can do this one, because you can raise both sides to base e. And the reason why I'm writing them really, really big is because exponents are always smaller in size than the base. So it's just trying to drive home the point that this and this little 2, those are now exponents of those e's. And now you can go like this. And you just have x over 1 minus x on the left. And then on the right side, you have e squared. And then from here, now it's just the algebra. So any ideas on what to do?
Could we
Multiply
Right.
the denominator.
Say that again, multiply by the what?
The denominator.
Yeah,
That's,
because essentially we're just going to cross multiply stuff. So x times the 1 equals e squared times your 1 minus x. And then we just have to distribute so now there's no more fraction to worry about, which is nice. And from here, you just get your x's to one side. So this negative xe squared will swing it over to the left. And once your x's are all together, what would you want to do with them? Or what would be your next step?
take them out? And then put them to the parentheses.
Yeah, factor it out. So if you factor it out, what would be left over in here?
1 plus e squared.
1 plus e squared. And then just divide by that stuff in the parentheses. And there is your solution for x.
And then like a quick question, we couldn't, for the e, we can't bring the 2 down and put it in front of the e, right?
This too, like pull it down.
Yeah, pull it down. Okay.
No, that only works with logarithms. It doesn't work with e.
Okay.
So yeah, this one, that's as simplified as you can get it.
Okay.
So if you're going, how on earth would I type that into the exam? Well, chances are if it was a problem like this where your answer is coming out like that, that's going to be a free response.
All right.
Typically the fill in the blank questions are like if you might end up with fraction, but something like pi over 2 or 3/4, or something that's easy to type, not something like this that's going to be dependent on parentheses.
Got it. Right. Okay.
So let's try one that's a logarithm. So let's do log base 2 of x plus log base 2 of x minus 4 is equal to 5.
So we're first gonna
multiply.
Mm-hmm. Yeah. So the logs, again, they're on the same side. So you can take the stuff in there and multiply them together. And you might as well just distribute it right now because you're going to multiply them. So that would be x squared minus 4x, and that's equal to 5. Okay, any ideas?
Could we complete the square there, or
No.
so then,
It's like you could, but it wouldn't really help you. Like it wouldn't help you
Okay.
solve for x.
so
You can do
then-
that, but you typically don't want x in a log from when you complete the square.
Okay. And we could put the x over the x squared over 4x to cancel out the
can't-
x's.
You can't do that because it's not log of x
Oh,
squared
right.
minus log of 4x. So once you've combined your logarithms together, just like we did in example A, we wanted that ln to cancel off. So we can do pretty much the same thing as what we did here. We used e because it cancels out an ln. But we don't want to use an e here because that wouldn't cancel. So instead of an e, if you had to take a wild guess, what number should we use?
2.
2. So whatever this little base is, that's the base you're raising it to. So that's gone. So your x squared minus 4x is on the left. And then on the right, you have 2 to the 5th. So 2 to the 5th, we're going to evaluate into 32. And now you're trying to solve the quadratic. So you can now, if you want to, you can complete the square, or you can try to factor or use the quadratic formula. But what should you do before you really try any of those?
Move the 32 to the left side.
Yeah, set it equal to 0. And then run through your list of options. So personally, I would, once I move it to 0 or set it equal to 0, personally, I would try to factor it. And then if it didn't factor, then I would use the quadratic formula. And then if it told me to, that's when I would complete the square. But if complete the square is your favorite method, you can totally use it. All right, so what would this factor into?
X minus 8 and then x plus 4.
Yeah. So x is going to equal -4 and a +8. However, you want to make sure that you're checking your answers when they're coming out like this one. In the previous example, when it's coming out crazy like this,
right,
you can pretty much assume that this is correct, because that would be hard to check because you don't have calculators. But answers like these you want to check, because you don't want a solution for x that's going to create a negative number inside the logarithm. So this -4, if you plugged it in to either of them, if you plugged it in there or there, it creates a negative in the log.
right.
So it can't be a solution. The 8, that makes it positive here, positive in that one. So that one is good to go. So you can keep it. Sometimes you can keep both solutions. Sometimes you toss out the positive answer and keep the negative. Sometimes you don't have any solutions, so there is no solution. It just depends on what answers you came up with and how they affect the original logs. And I'll always go back to the original equation. Don't go to one that's in the middle or where you've combined or moved things. You always go back to the original to check it.
Got it. Sounds good.
Okay, and then just really quick, since you said all of it, let's graph that. Y equals ln of x, ln of x minus 2. So with ln's or logarithms, what kind of an asymptote do they have for the graph? Is it horizontal or is it vertical?
It's vertical, right?
Mm-hmm. And it's going to be a vertical asymptote at wherever or whatever makes this quantity 0.
So it would be at 2.
So it's at 2. And then it arcs over this way. And it definitely hits the x-axis. And with logarithms, there was kind of a little trick that you could use, or at least for this class. Where do you think that x-intercept is?
I want to see a 4.
Almost, that's too much.
At 3.
At 3.
Okay.
So typically the asymptote and the intercept are 1 apart. And if you're not sure, then take your logarithm and set it equal to 0 and solve for it. So you can go back and, stick in the giant E's. E to the 0 is 1. Add 2 to both sides, and x is going to equal 3. The shortcut for doing it this way, for doing this, trying to solve an equation, is figure out what makes the inside 1. That's where you ended up anyway.
Oh, okay.
Because ln of 1 is 0. So if you figure out what makes the inside 1, then you got it.
Got it.
So let's check that one. So y equals ln of 4 minus x. The vertical asymptote's going to be at 4. Because that makes the inside 0.
Right.
But when the x is negative itself, what does that do to this curve?
Does it make it go the other way?
What do you mean by the other way?
Yeah, so instead of going to the right side, does it make it go to the left side?
Yeah. Yeah, it's going to flip it over.
Flip it right
Across the asymptote. And it's going to go over like that. So where is your x-intercept?
At 3.
At 3. Because it's still just 1 apart.
Right.
And if it asks for it, where's your y-intercept?
Y-intercept is set x equal to 0, so 4.
It looks like it would be tricky, but it's not.
Would it be 4?
Nope. There's a 4 in it, but you kind of took something off for some reason.
0, 4?
No. You kind of erased something.
ln, right?
Yeah, the ln. Because you're just plugging 0 in for x. You're not, erasing the ln part of it.
Right.
So it's ln of 4.
Oh. Oh, wow. Okay.
So that would be your y-intercept. The first one that we did over here, there's no y-intercept because it can't go past your vertical asymptote.
Right.
but this one's got one. So sometimes there's one, sometimes there's not. It just depends on the function. Okay, so that's about it for the logarithms.
For logs, yeah.
I mean, they can come up in random places from time to time, but if you know how to work with them with all the stuff that we just did, then you'll know how to work with them when they're in other things.
I got it. Sounds good. Well, I'll let Helen go if she has any questions.
I was wondering if we can go over problems with like trig identities.
Where,
like double angle formulas. Like
where you have to solve an equation, or where you have to prove something.
Let's see. Well, can we do a little bit of all of them?
Sure. Let's see, let me pull up. Did you have one in particular that you've been staring at?
I'm trying to look for one. Let's see.
Let's see if I can find one. And I'm really glad I'm not giving an exam today.
I know, right?
Canvas is still not loading.
I'm
okay.
looking at the textbook really quick.
Okay, well, I found a couple of equations, so we can start there.
Okay.
Or did I? Nope, I lied. Oh wait, no, there's one. Okay, so like cosine of 2 theta plus root 3 cosine of theta plus 1 is equal to 0, and we're going to solve on the interval 0 up to but not including 2 pi. So when you go to solve a trig equation, you want to make sure that if there's more than one trig function in there, that the angles are the same. And if they're not, then you're going to have to do something to get them to match, because you can't solve it when one angle is 2 theta and the other one is theta. It's just not going to work. So your options are to try to make this angle become theta, or try to make this angle become 2 theta. And it's a lot easier to make this one go down to theta than to start playing with this one. This one, like, you could do it, but you would have to be extremely creative. And it would be rather lengthy. So we don't want to go the long way. So we're going to use a double angle identity with this one to break it down and get the angles, the angle to match up to that. So with cosine of 2 theta, we have 3 options. So your first option or one option, I guess, is cosine squared minus sine squared. A second option is 2 cosine squared minus 1. And then your third option is 1 minus 2 sine squared. So you can choose any of the three. They will all work, but one of them is going to be quicker than the others. So based off of the equation here and what's in it, which one of these three is going to be the best choice?
Number 2.
Yeah. And mainly because we don't have any other term with a sign in it. So let's not throw in like another option, another trig function if we don't have to. So yeah, we'll go with that one. So we're just going to stick it right in there. And the rest of it is going to just be the same. All right, so we can combine like terms. So the ones cancel. And once you get everything combined, it's still a quadratic equation. So you can still run through your options to try and solve for theta. The easiest one here would be just to pull out the cosine. And then you can solve for cosine of theta. So first it's going to equal 0. And then the second is going to equal negative √3 all over 2. And then you can solve each little equation there. So where does cosine equal 0?
At 1/2.
1.
Not cosine of 0 is 1. But what angle makes cosine equal to 0?
Pi over 2.
Pi over 2.
And 3 pi over 2.
3 pi over 2. Okay, so there's 2 of your solutions. And then where does cosine equal a negative √3 over 2?
At 5 pi over 6 and 7 pi over 6.
Nice.
Yep.
Okay. One second. Just kind of realize if Canvas is down, then no one can look at the link that I sent for the review session.
I had to copy the link and then open it in a new tab to join.
This happened a year ago. I'm really hoping it's not the same problem. A year ago, they updated the equation editor in Canvas, and it like cascaded havoc across the country.
Oh no.
It made it so like it started really small, like you couldn't see, like in random places, negatives were missing from the expression, and
right.
And then all of a sudden, like it just you couldn't see anything. All you could see sometimes was code, or it was just coming out as gibberish.
Oh my.
Yeah, right before finals.
I know, right? You could probably try sending the link through email or something, but I don't know if that be super time consuming.
Hang on, I gotta stop sharing for a second. Okay. Let's see if it works through that way. Okay, well, I got it.
Yeah, I got it too.
Okay.
Yeah.
Okay. So is this kind of what you were talking about as far as solving where it had one of those?
Yes.
Okay.
Yeah. Do you know if the exam will be kind of similar to all the exam study guides?
I do know that, and yes.
Yeah.
Yeah, so it'll have the same format as the other exams too. So there'll be a like a multiple choice section, and then another section that has like all the like fill in the blank or true false questions, and then the last few questions will be the free response ones.
Okay, but for the most part, it's like I know the exam has like a couple questions for each chapter.
Mm-hmm.
Like the ones that have the most questions in each chapter, that's probably going to be the same for the exam. Or is it more of a certain chapter than others?
No, it's pretty even.
Okay.
I think. I think it's pretty well. It's pretty broad. So I mean, it's hitting everything pretty much. There might be some like a couple of minor things that it might not hit, but the major concepts are going to be in there. So I mean, there's going to be graphing. You're going to be solving equations.
Okay.
It's like those things are pretty major. But I mean, that's because it was involved in a lot of chapters. So yeah, it's pretty split. So how I would study is to just go back over the exams again, and redo them, as well. Hopefully you can access them, and then I would hit the study guides again. And between those 6 things, that should do it. I mean, if you really want more problems, you could try the quizzes or go over the homework again. But I mean, that's a lot of problems right there with just the exams and the study guides.
Yeah. Oh, actually, can we go over the finding the rectangular coordinates? And well, the equations. Writing the equation.
Like
coordinates.
when you're converting from polar,
yes.
like when you have r's and thetas and you want to get it into x's and y's.
Yep.
Yeah. Okay. Did you want to try a proof that had a double angle in it, or are you good?
What's that?
Did you want to try a proof that had the double angle stuff in it, or was that equation good?
That equation was good.
Okay. If there is a proof on the final, there's only going to be one of them. I'm not going to give you like 3 or 4.
Okay.
Okay, so you're wanting to, let's see, convert. Let's go r minus 4 cosine of theta plus 6 sine of theta equals 0 into rectangular. Something like that.
Yes.
Okay. So when you go into rectangular, there's a couple things you can use. A few. Because we have all those conversion formulas. So one of them is r squared equals x squared plus y squared. It's basically the Pythagorean theorem. So you can use this one, or sometimes the one that might apply is if you took the square root of both sides. Because sometimes you might have a single r that you need to take care of, and that would do it. So it just depends on what's in there, on whether it's going to be this one that applies or this one. The other ones, x is equal to r cosine of theta. Y equals r sine of theta. And then theta itself is equal to the inverse tangent of y over x. So this one you would really only use if there's like a random theta on its own and it's just not going away somehow. That's when you could throw this in and that would take care of it. Okay, so we've got the cosine and the sine in there that we need to deal with. Well, we can't change them, excuse me, into x and y until there's an r in front of both of them. So we're actually going to take this whole equation, and if we need to multiply an r to both of those, we're going to multiply an r to everything, because we can't just multiply to just a couple of things in there. You got to multiply to the entire side, or in there to both sides. So that's going to make it r squared minus 4r cosine of theta plus 6r sine of theta is equal to 0. So now you can do what we wanted to, in that you can change this r sine of theta out, you can change the r cosine of theta out, but at the same time, we can also change out the r squared. And so it's just x squared plus y squared minus 4x plus 6y is equal to 0. And that's as far as you need to take it, because this right here is in rectangular form. The book sometimes went further and they started to complete the square and do all this fun stuff. But you don't need to. You can if you want. It's not. I'm not going to stop you, but it's if all they want you to do is just convert it, then just get rid of the r's and thetas, and then you're fine. Or if you can add and subtract things together, like combine like terms, do that. But you don't have to keep going with something like that.
Okay, thank you.
Yeah. Let's see. Are you okay with inverse trig functions?
I might need a
either of you
practice on those.
need more practice.
Yeah.
Okay. Let's go ahead and practice. Okay, so let's do inverse sine of 1/2. And some people are just really good at these and they can do them right in your head. If you can't do it in your head, that's fine. You just need to start drawing things out. So inverse sine, it's either going to end, when you draw something, it's going to end up in quadrant 1 or it's going to be in quadrant 4. So out of the two quadrants, which one do you think it's in? 1 or 4?
4.
It's actually in quadrant 1.
1.
So if this number is a positive, it's automatically in quadrant 1. And that's true for any inverse trig function. So if this was inverse cosine or inverse tangent or inverse whatever, when you draw it, it's if it's a positive in there, you're just always going to stick it in quadrant 1. When it's negative, that's when it can start to move around to somewhere else. So you can draw your triangle, label the sides. So opposite over hypotenuse. And then you can use Pythagorean theorem or realize, oh, this side's just going to be √3 because it's a 30, 60, 90 triangle. So your answer is going to be 30 degrees, but you are going to want to answer in radians. So 30 degrees is how many radians?
Pi over 6.
5 or 6. If you don't like the triangles, that's fine too. You would just try, you're just trying to match up on the unit circle what angle has a y coordinate of 1/2. Excuse me. And that would be your pi over 6. So you can draw triangles, you can go out the unit circle, either way you want. And it'll still get you to the same answer. Where it gets a little tricky is if there is a negative thrown in there. So you have to know where things can go if there's a negative. So inverse sine, we talked about earlier, you're either in quadrant 1 or quadrant 4. So because it's negative, that means you're down in quadrant 4. So same thing, you can either use the triangle or you can go off the circle. Just depends on what you like and what you've been taught. I always did the triangle because I could always draw it. I didn't have to memorize the circle. And it always worked. So that's still a 30, 60, 90. So it's still 30 degrees for pi over 6. But it can't be the exact same answer as, when it's a positive. So if you're in quadrant 4.
I'm sorry, Professor. I have to I have to pick up my kid. I think he got out early today.
Uh-oh.
Lost track of time. They you still be recording this, right? Okay.
Yeah.
Okay. Thank you so much.
Sure.
Bye.
See ya. So it just has the negative in front of it. So instead of being pi over 6, because you're in quadrant 4, it's negative pi over 6. And what I see a lot of people wanting to do, let's change it. Let's do inverse sine of negative root 3 over 2. What I see a lot on quizzes, exams, or wherever, homework questions, they'll say, oh, that's easy. That's just 5 pi over 3 or something like this. But it's not right. Sine of 5 pi over 3 is negative root 3 over 2. Yeah. But you're working with inverse sine here. So inverse sine, your answers, they're always in an interval from negative pi over 2 to pi over 2. That's the range for inverse sine. So whenever you give an answer like this, you better make sure that this answer is in here. If it's not, then you've got to convert it around or give an equivalent angle that's at the same location so that it does fit into here. So for this particular one, it would be 60 degrees or pi over 3. But again, you're in quadrant 4, so it's a negative.
That's what I was about to ask, because on the study guide for, I think it's the second study guide, one of the questions was sine inverse of sine 7 pi over 4, which is kind of similar. And I thought it was, what's it called? I forgot what my original answer was, but it ended up being negative pi over 4.
Oh,
kind of like it's similar to this, or?
Yeah. We can do inverse tangent. Yeah, so inverse tangent of -1, I saw it a lot. A lot of people wanted to say that it was 7 pi over 4. It's like, nope. The answers for inverse tangent all have to fit in almost the same interval for inverse sine. It's just you can't include negative pi over 2 and pi over 2. So that's why it's negative pi over 4. So again, like if you just draw it out, it should tell you like what the answer is, more so than the circle. The circle gets a little dangerous because the circle, it's going to have the right coordinate.
Right.
But the angle that's listed there is this one. But you can't use this angle because it's not in there.
Mm-hmm.
So you have to go off the reference angle of that triangle. So the triangle to me is a lot nicer to use because it doesn't fail. The circle, it works as well, but you have to tweak it to get it to do what you want.
Okay, so when it's something like that, you take the reference angle, right?
Yeah. Mm-hmm.
Because I usually use the circles for like simple trig functions. I usually just use a circle, just
Okay.
because it's much easier for me just to like look at the circle, find the coordinate, and then just use the radian. But when it comes to like inverses, that's where I start using the triangle.
Okay.
Or I try to.
Yeah. I will caution you, like you said, that you have to look at the circle.
Mm-hmm.
When you get to calculus, they're gonna kind of expect that you're not looking at that circle anymore.
Oh, okay.
And so you're gonna want you like those values. So like tangent of pi over 4 or sine of 5 pi over 6, like you got to be able to come up with your answers pretty quickly. And if you have to keep looking at the circle, you're losing time, I guess is the best way to put it.
Okay, so it'd be better just to become more familiar with the triangle, right?
Sure, or get familiar with something enough to where you don't necessarily have to keep doing it out, or where you don't have to pull the circle out every time.
Right.
So just a word of caution.
Okay, sounds good.
It's like, and I teach calculus, so I know.
Right.
Okay, did you have any other questions you wanted to hit?
Yeah, I was I wanted to go over I forgot, this is chapter 9. It's it says, this is from the study guide. It was let z equals 2 parentheses cosine 205 plus I sine 205 degrees parentheses, and w equal 4 parentheses cosine 85 degrees plus I sine 85 degrees parentheses. And then it says, leave your answer in polar form with argument in degrees.
Okay. Both of those, or one of them?
One of them is z equals 2 parentheses cosine 205.
Okay. And then part A is z times w.
Right, yeah.
So the formula goes, you would take the r of z and multiply it to the r of w. Oops. And then it would be CIS the theta from z plus the theta from w.
Okay.
If you look at the notes have, instead of z's and w's, they have it. I think they have 1s and 2s or something. But I mean, it's the same thing. So just take the r's that are given to you and multiply them together. So in this case, that's a 2 and a 4. And then take the given thetas. So the one for the z was 205. And the one for the w was 85. And then just add them together. So 205 plus 85, that would be 290. And then it said to leave your answer in polar form with the argument in degrees. So that's all you have to do. If it said, write your answer in the form of A plus BI, what that means is that you would have to do, cosine of 290 plus I sine of 290. You'd actually like evaluate them out and then multiply by whatever numbers out here. but I'm not going to do it to you on one like this because 290, that's like, you can't draw a triangle with that, and then you can't draw or go off the unit circle either.
I'm talking about the A plus BI. Could we do problem 10 and 11 also?
Sure. Did you want to do part B or?
Oh, yeah, part B also. Yeah, sorry about that.
Okay. No, you're good. So B was Z over W. So it's kind of the same thing, but just kind of a little bit opposite. So when you're multiplying, you multiply the R's. When you're dividing, you would divide the R's. Just pay attention to which one's on top.
Okay.
Because if it's a W over Z, then these R's will be up flipped upside down. And then you're going to take the theta for the Z because that's the one on top. And minus the theta from the W because it's underneath. So the Z, its R was 2, the W's R was 4. And then just subtract your angles. So 1/2 CIS of 205 minus 80 degrees. There you go.
Sounds good, thank you.
Okay, and then you said number 10, right? Right there.
Yeah, number 10 also. Yeah, sorry about that.
2 cosine of 50 plus I sine of 50, all of that raised to the third power in standard form A plus BI. Okay, so when you raise that complex number to a power, you take the R and raise it to the same power, so it'd just be 2 to the third. And then you're going to take the angle that they give you, which in this case was 50, and don't raise it to the exponent, because one, that's going to make your number really big. And it's going to look really weird if you do, because it's an angle. So instead of raising it to an exponent, you're going to multiply by the exponent. So the R gets the same exponent, but the angle gets multiplied by the exponent. And if it said leave it in polar form with the argument in degrees, then you're done. But this one wants you to write it in rectangular form, or A plus BI. So you have to evaluate the 2 trig functions that are in there. So we're going to evaluate cosine of 150. So what's cosine of 150?
Cosine of 150 is negative square root of 3 over 2.
Okay.
And then sine would be 1/2.
Yeah. So the only thing left to do from here is to take the 8 that's on the outside and just distribute. So that'll be negative 4 root 3 plus 4i. And that's matching the formula or the form that they wanted you to do.
And then if we could please do 11 as well.
Yeah. Okay, so 11. This is where you're finding all complex fourth roots of -16. And we
Right.
can move them in polar form with argument in degrees. So we don't have to, for your roots, we don't have to expand them out like we did before.
Okay.
Leave it with r's and thetas.
If it said we'd have to put it in that same format, right? The a plus bi.
Say that again.
If it did ask for the answers in standard form, we would have to do the same process we did for part 10, right? For question 10.
Yeah. Yes, and the angles would they wouldn't be weird. Like they would all match up to the unit circle.
Okay.
I'm not going to ever ask you to write it in standard form if like you have an angle of 20 degrees.
Right.
Something where you would need a calculator. So if it comes out that way and you're supposed to write it in standard form, then something's off. You're going to want to fix it.
Okay. For sure.
Okay, so negative fourth roots of -16. You're going to start by taking the fourth root of the r. And if there's a negative sign in there, just drop it. So we're going to get a 2. So that 2 is going to sit outside, kind of like this 2 is right here. So there's going to be a 2 and then CIS, and then we got to figure out the angle.
Okay.
So first off, we need to know where that point is so we can have something to work off. So -16, if you were going to plot it on the imaginary axis, where would it go? So the x-axis, that's the real part. The y-axis, that's the imaginary.
Would you plot it on the imaginary?
You would if it was a -16i.
Oh, okay. So then you just put on the real.
Yeah. So we're gonna go straight out this way. So if you're gonna start at 0 and like rotate all the way over there, what angle is that?
180.
Mm-hmm. And there's a formula to figure out that angle. Remember what it was?
Not off the top of my head.
Almost asked Helen, but she's not here. It's like, oh, wait. So you take the angle that goes with the point, the 180, and you're going to divide it by, in this case, 4, because it's the fourth root. If it was the q root, then you would divide by 3. If it was the fifth root, you'd divide by 5. Seventh root divided by 7, and so on and so forth. And then plus it's got this little 360 over and divide by the 4 again. Times the K. And so this right here is kind of like your generator to give you the rest of, or to give you all of the roots. So just simplify it as far as you can. So like 180 divided by 4 is 45. 360 divided by 4 would just be 90. And then you can start plugging in numbers for K to give you the roots. So the first one is always going to be Z sub 0. So when K is equal to 0, that knocks out that term. So it's just 2 CIS of 45 degrees. Z sub 1, you can plug 1 in for K. So it's just 45 plus 90. Then you can plug in 2 for K or just add another 90. So 90 plus 135 going to be 225. And then if you plugged in 3 for K and worked it out or added 90 again, you get 315. So those are your 4 complex roots.
Okay, that cleared it up a lot because I was like,
Oh,
really sure how to do these.
so if it said like find the complex fifth roots, like for example, you should end up with 5 answers.
With 5 answers, got it.
If it said the complex cube roots, then you should end up with 3. Complex eighth roots, you'd have 8 solutions. So that kind of helps tell you how many you should get.
And then so if it said like find all the complex fifth roots, you would put a 5 outside of the square root of 16, right?
Yeah, so you'd be doing the 5th root of 16, and then so yeah, 5th root of 16, and then these denominators here would both be 5s.
Okay. And I don't know if we could access Canvas still, but I wanted to go over
Let's see.
2 of the questions on the last exam.
Oh, wait. Maybe it came up. Or maybe it didn't. Oh, no, hey, it worked. Let's see if I can, oops. Well, it opened. Let's see if it'll let me get into something.
Well, it's letting me get into everything.
Yeah.
Too.
Okay, you said the last exam?
Yeah, exam 3.
Okay.
And I want to go over question 13 and question 14, and then the we had to, and question 24. I just wanted, for question 24, I just wanted to see the ones that I got wrong.
On 24. It didn't tell you which ones you got wrong?
Yeah, I did, but I'm still
okay.
having like trouble, like, oh, like, why is it wrong, you know?
Gotcha. Okay, so 24. Let's just draw that graph. 2. Okay. All right, so let's see. Okay, so you missed B. So the limit, a couple other people missed this one too. The limit as x approaches -1 of f of x. So you put does not exist. Do you know why? Do you remember why?
Of x equals 1, of x equals -1. Let's see. I put D and E just because there's not like a point on there, you know.
Well, there is there a point right here?
I mean, yeah, that's what
Yeah,
first I thought it was no, but then I'm guessing there is a point there.
there is. If there isn't a point somewhere, there has to be one of two things. There either has to be a vertical asymptote or a hole.
Or a hole, okay.
Because yeah, like you wouldn't argue anywhere else. Like if I said, okay, well, is there a point here? You said, yeah. Is there a point there? Yes, there, yes, there, yes. Well, that's all. That's because it's on the curve or the graph.
Right.
So just because there's not a physical closed circle there doesn't mean there's not a point there.
Got it.
Even if there was an open circle there, the answer would not have been D and E.
It would still been 1, right?
Yeah, it's 1. Because if you trace in from the left side, you approach y equals 1. If you trace in from the right side, you still get to 1. So the limit is 1. All right. And then part E, the limit as x approaches 1 f of x. So that one oh wait, no, you got E right. That one is D and E. Sorry, you missed part F. So part F was just, okay, well, what's the function value? So when x is equal to 1, what's the y value that goes with it? So you put D and E. So I'm guessing it's because you didn't see that there was a point up there.
Right. No, I did take notice of that point, but since there's like not a connection between, this is what I thought, because there wasn't a connection between the
Like
point.
these
Between
connect.
those two, yeah.
Okay, that's more of the continuity. But if you've got a point at that x value, then you're also going to have a y value that goes with it, whether it's like kind of connecting the curve or above it or sometimes below it. If there's like a solid dot somewhere or solid part of a curve, then you've got a point. So for this one, it's equal to 3 because that's where your closed or your solid dot is.
Right.
So you've got a function value.
So if the dot wasn't there, what the answer would have it been D and E?
Yeah. So if it was totally gone, then yeah, it would be D and E. Okay, and then then G as x approaches 2 from the left. So what'd you put? You said it was 1. Oh, I think there's a little typo in there. Not on you. I think there's a typo in what Canvas was looking at. Because it should be 1. Not sure why it thought it was -1, but it did. Because you're approaching it from the left.
Right.
So that should be a 1. Okay, I'll have to go and fix that. So 24G. Yeah, correct. So your score goes up by 1.
There you go.
And then the 9th one. So as X approaches 2, okay. From both sides. Okay, so you put 1 for that. So it's really D and E, it doesn't exist. Because if you trace in from the left side, you approach 1, but if you trace in from the right side, you approach 2. So they approach 2 different values. Wait, whoops. Sorry, X approaches 2, same thing. If you approach from the left side, it's down here. If you approach from the right side, it's up there. So they're split.
Okay.
So if they're split like that, if they approach two different values, then the limit cannot exist. Oh, so that, I'm sorry, but I don't know why I was doing this, but I was looking at the wrong value for G. It's 2 from the left, and I did 1. 2 from the left
Okay.
does approach -1.
-1. Okay.
Yeah. Okay, so your score stays as it is. Sorry, I don't know what I saw, but
No, you're good.
2 from the left. Yeah. If it was 2 from the right, then that would have been at 1.
That would have been at 1. Okay. Yeah, and I did put 1 for that one.
Okay, so that takes care of 24.
Mm-hmm.
Which other ones did you say?
It was
13?
13, I believe.
Yeah.
Yeah.
The one with the soccer game?
Yeah, the one with the soccer game.
Okay, so you got part A and then part B. What is the maximum height? So for this problem, you need your X equation and you also need your Y.
Right.
So your X is your initial velocity times cosine of theta, all of that times T. Your Y equation is, what is it?
My Y equation is oh my goodness, what is it? It is, oh wait, that's wrong one.
It's -1/2 G T squared plus your V sub 0 sine theta times T, and then plus H, or your initial height. So a lot of variables going on everywhere.
Right.
But most of them, they should all go away except for X and Y and all the T's. But everything else should be given to you. So your initial velocity for yours, so there are 2 different versions. Yours is 96. And your angle was 30. So cosine of 30, root 3 over 2. So your x is 48 root 3 times t. So the g on the y, that's going to be one of two values. It's either 9.8 if you're in meters per second, or it's going to be 32 if you're in feet per second. So with this one, you're in feet per second. So that's your 32. The v is still the 96. Theta is still 30. And then the h, you kicked it from the ground. So that means that the ground for your h is at 0.
So I was right.
Yeah, if it's just flat on the ground has a height of 0.
Right.
So y is equal to negative 16 t squared. Sine of theta is, oops, I forgot the t. Sine of 30 is a half. So half times 96 is 48. So for part A, so how long is it in the air? So you take your y equation, which you did, set it equal to 0. And solve for t. So you can pull out a negative 16 t. So t is equal to 0 and 3. Well, it can't be in the air for 0 seconds because he kicked it. So 3 seconds. Okay, so part B, what is the maximum height? And you said it was 3. Were you taking the same value from here, or did you, or how did you get the 3?
I think I did. I'm trying to find my. I'm just gonna download it because I can't find my sheet where I go. See, I think that's what I did.
Okay, so that's the time that it takes to go all the way up and then to come all the way back down. It's wanting to know what's the height up here. So at 3 seconds, you know the height's going to be 0 because it that's when it hits the ground again. So there are a couple ways to do it. One of them is to use, because you need the time that it reaches the max height. So that's just, you just have to use negative b over 2a. And that's coming from your y equation again. So it'd be negative 48 all over 2 times negative 16. So you have negative 48 over negative 32, which is 3 over 2. So that's the time that it reaches its max height. The other way you can do it too is take the average of your times when it hits when it's at the ground.
Right. That's I think that's what I did.
So that, and it matches up. It's 3 halves or 1.5. Either way, you can get it. Once you get it, then you got to plug it back into the equation to figure out the height. So plug in 3 over 2 in for t. And then just start working it out. So 4 goes into 16 4 times. Negative 4 times 9 is negative 36. 4 goes into 48. Or sorry, 2 goes into 48. 24 times. 24 times 3 is 72. And negative 36 plus 72 is 36.
Got it.
All right, and then part C. When does the soccer ball first reach a height of 20? So now you're going to take your y equation and set it equal to the height that they're asking for. So in your case, it was 20. And then just solve for t. So I'm going to move everything over to the right side so I can get my t squared to be positive.
Right.
48t becomes negative. And you just want to solve that quadratic equation. But before I do, if there's a number that goes into all 3 of these, I'm going to just divide it out and make the numbers smaller.
Right.
So we can divide everything by 4. And you don't have to do it if you don't want to or don't see it. It's just helpful if you can. And then you can either, factor, complete the square, or use the quadratic formula. So it factors 2t minus 5 times 2t minus 1. So t equals 5 over 2. And it also equals 1/2. So when does it first reach a height of 20?
It would be 1/2. Okay. So I guess I did the steps right. I just didn't do the when t equals. I guess I just did 2 and then the 2 over 5 instead of 5 over half. That was a very simple and dumb and silly mistake,
Well, yeah, your answers are upside down.
Exactly. Yeah, there you go. Upside down.
And you gave 2 answers. There should have only been 1.
Only 1, right? Yeah.
Yeah.
Got it.
So I think the other version said when's the second time it reaches the height of that. So that would have been yours, and your answer would have been 5 over 2.
Got it. Right.
Okay, and then D, when does a soccer ball reach a distance of 96 root 3? So now you're going to go all the way back to your x equation. Set it equal to 96 root 3.
Oh, wow.
And then solve for t. So the root 3's cancel. 96 divided by 48 is 2.
That's funny. Like now I'm looking at this and I'm like, oh my God, how did I make this mistake?
It happens.
It happens, but oh,
I mean, to everybody, not just students. I do it too.
Right. Yeah, and then
like, yeah, 4 plus 4 is 9.
Right, I know, right? It's like, what the heck? Yeah, I did that once on one of my old homeworks, and my teacher was like, are you okay? And I'm like, yeah, why? He's like, look what you put. I think it was like 3 plus 2, and I put I think I put like 9 or 7. He's like, that's not it. I'm like, oops. Like it was because it was leading
right.
to exactly, yeah. It led to the thing equals 3 plus 2, and then I put like some other number, and I'm like, oops. That's pretty funny.
Let's see. Do you want to talk about number 14 for a second?
Yeah, 14 also.
You've got some interesting
answers.
So give the first 4 terms of the sequence. So you're plugging in numbers for every n, and it looks like you only plugged them into the exponents.
That's probably what I did.
So like, let's see, we've got -1 to the n plus 1.
Oh, I see.
N to the -1 to the n. So when n equals 1, that'll make this one 2. That'll make that guy a 1. And I think that's why you missed it, because you left that as an n.
Right.
So this comes out as a positive. 1 to any value is just 1. So n is equal to 2. -1 to the third. This n now becomes 2. So -1 to the third is a negative. -1 squared is 1. So that works out as -2.
Right. I think a lot of these ones, I think I did them like, I tried to at least do them mentally, and I wasn't like putting in the value for n, like you said.
For all of them, yeah.
For all of them, yeah.
Okay. All right. So, all right. I'm guessing you have a question on the limit ones. Or did you figure those out? So like 16, 17, 18, 19.
Yeah, I haven't had a chance to. I was gonna look at them earlier, but I didn't have a chance yet to.
Okay, well, that's all right. So evaluate the limit. So the limit is x approaches 5 of x minus 3 over x squared minus 16. The first thing you should do is try to take this number and just stick it in there and see if it works.
Right.
So if it gives you an answer back, then you're totally fine. If it gives you a 0 in a denominator, you're going to have to do something to this and get it to the point where you can plug in the 5. So in this case, you can just plug it in. Nothing bad is going to happen. So the top is just a 2. The denominator just be a 9. So just 2 over 9.
Oh, and you put the answer. Oh my God. I thought, no, see, I got all the answers, but it says if the limit is unbounded, please identify it as either negative infinity or infinity. So I just typed, since it was positive, I just typed in infinity. And whenever it was negative, I typed negative infinity.
Okay. Yeah, that's not what that meant.
Okay. See, that's, oh my goodness.
That would be, there was one of them in here, I think. Where is it?
Oh my God.
So 21, I think I had 3 different versions.
Right. I got that one right.
You did.
Yeah.
But another version was this. So you had it where x is going to 0. One other version was as x approaches 0 from the right.
Okay.
Of 1 over x. For all 3 of them, you can't plug in the 0 and you can't manipulate this function. So if you can't manipulate it, or simplify it or break it down or do anything, then you're forced to use a graph.
Mm-hmm.
So for this one, as you come in from the right, it's just shooting up all the way. There's no bound to it, it's unbounded. So it's going off to infinity.
Oh my goodness.
So that's what that part was talking about. If it goes up forever, it goes down forever. Just inf for negative inf.
Oh, okay. So I was, oh my goodness.
And the
That's
reason
funny.
why I said not, or to type in like INF instead of the actual word infinity
Right.
is because many people don't know how to spell infinity.
Infinity, right?
So it's just easier. INF.
Right, there you go.
Because yeah, Canvas is such it. If you misspell it, it will mark you off because it's looking for the exact thing that I said was the answer, and if it doesn't match it, that marks it wrong.
Got it. And then going back to the
tough.
example, yeah, sorry, going back to the example, the one you just showed me, that x from right side 0. So if it was coming in from the left side, it would go into negative infinity, right?
Yeah.
Okay.
Yeah, and for yours, 0 from both sides. That's why it was D and E, because they were approaching two different things.
Got it. All right. Well, I think, yeah, those were all the questions I had. So.
Okay. Yeah, the free response looked pretty good.
Decent, yeah. I think that's pretty much it. Oh, and I had a question for the, I think it was for the quiz that we got extra points for. Are those, because I think I missed 4 points, but because, I mean, it was the right answer, right? For quiz 11.
Oh, yeah, there's a right answer for him.
Right.
Quiz 11.
Yeah, quiz 11. So for those ones, am I going to get the 20 out of 20? Or am I going to get just like 18 or
no,
20?
so it's not counting into the grade at all. So I mean, there's a score,
Right.
but it's not. Your score is not being added into the quiz point totals. So
Okay.
it's counting as a bonus, just purely as bonus points for the exam. That's it.
Oh, okay.
So it doesn't count anywhere else in the grade.
Oh, okay.
So the graded quizzes are now just 1 through 10 and 12.
Okay. For sure.
Yeah, it took a while for me to figure out how to do that. But I think I got it. So that's why there's a category that's called bonus quizzes.
Right.
Bonus quiz, and it says 0% of your grade. So it's not affecting anything. But I had to put it somewhere where it wouldn't do anything. Because Canvas is picky like that.
Oh yeah, Canvas is really picky. Yeah. Well, I think I'm gonna head out now.
Okay.
Yeah, because those were all the questions I had. So.
All right.
Yeah. I mean, there's only like 20 minutes left.